Welcome students. In the last session we have discussed about reproduction in detail. Now today in this session we shall discuss about another important chapter in the chemistry, that is carbon and its compounds. Yes, we know that most of the elements are existing in the nature. It may be metal, it may be non-metal, it may be metalloids. Among the non-metal, carbon plays a very important position because today we are using more number of carbon compounds in our day-to-day life. 80% of the substances what we are using is containing carbon and its compounds. So today we shall discuss about how these carbon compounds are using in nowadays gain a very much importance, why we are using more number of carbon compounds, and so on. The reason behind here is carbon has got certain properties, and because of the properties what we see in the carbon, today we can see large number of chemical compounds which are in the form of carbon compounds. And how these carbon compounds are actually formed? The question arises. These carbon compounds are basically formed by means of a bond which is known as covalent bond. Now just recall, when we have discussed about metals and non-metals, I have told about ionic bond. So what is this ionic bond actually? The bond where we can see the transfer of electrons between the atoms, where we can see the metals and non-metals are going to be seen. Between that the bond is going to be established, and that is called as the ionic bond, and those compounds are referred as ionic compounds. In the same manner, carbon compounds are actually formed by a bond which is known as the covalent bond. So through this covalent bond, many non-metals are going to be combined, or what we can say, one non-metal is going to combine with another non-metal by means of what we call a covalent bond. Thereby the ionic compounds show certain characteristics which differs from this covalent compounds which are formed by covalent bond. Now let us look into the systematic position of the carbon element. When you look into the periodic table, what is the position of this carbon? Let me see now. The symbol of the carbon is C. The atomic number of the carbon is 6. The atomic mass of the carbon is 12. The electronic distribution is 2, 4, which means 2 electrons are filled in K shell and 4 electrons are filled in M shell. And the valence electrons of the carbon is 4 and the valency is 4. Now let's see the meaning, what actually the meaning of covalent bond. Now, as I told, most of the organic compounds, most of the carbon compounds are actually formed by the covalent bond. So what is the meaning of this covalent bond then? The bond which are formed by the mutual contribution and sharing of electrons in the participating atoms, which means whenever the atoms are going to be participate, whenever there is a formation of covalent compounds, or what we can see the carbon compounds or organic compounds, there will be a sharing of electrons is going to take place between the two atoms. If the sharing of electrons is going to take place between the two participating atoms, then the bond established there is known as what we call covalent bond. And this covalent bond is going to be indicated by means of what we call a single line or double line or triple line between the two participating atoms. If you return a single bond or single line between the two participating atoms, then it represented as a single bond, which means a pair of electrons is going to be shared between the two atoms. If you write a double bond, that indicates there will be 4 electrons are going to be shared. If it is 3 bond, it will be 6 electrons is going to be shared. So like that. So depending upon the number of bond, we can say that how many electrons are going to be shared between the participating atoms. That's what I have shown here. Once again we can explain that if the participating atoms share 2 or 3 electrons, then we call them as what we call double bond or triple bond respectively. So double bond means 4 electrons are being shared. Triple bond means 6 electrons are being shared. If it is single bond, that means a pair of electrons are going to be shared. And whatever the compounds that are going to be formed by this sharing of electrons, we call those compounds as covalent compounds. Today we are seeing the covalent compounds in large number because of their properties. Sometimes the electrons which are going to be shared between the two participating atoms can also be shown by writing what we call dots. So by writing the dots, we represent that how many electrons are going to be shared. So the shading of electrons can be represented by means of what we call dot between the participating atoms. Now let us look into certain covalent bond, how it is going to be take place in these molecules now. Let us take an example of hydrogen molecule now. We know that in hydrogen molecule there is only one electron in its valence shell, which is known as K shell. Similar atom of hydrogen is going to be combined and there will be sharing of one electron between them and resulting in a formation of a single bond between that. That forms a molecule called hydrogen molecule. You can see in the image how the electrons are being shared, which is represented in the form of a dot, or sometimes it can also be denoted by a cross-like structure. We can use both the symbols to represent the sharing of electrons, either may be dot or cross-like structures. So those dot and cross represents the number of electrons in the outermost shell in the respective, that is chlorine molecule. Even in chlorine molecule, we can see the number of electrons distributed in the chlorine atom is 2, 8, 7. So 7 is the valence electrons present in the outermost shell. Totally the atomic number is 17. So similar atom of chlorine is also going to be shared. So when those two chlorine atoms are going to be shared, it forms a molecule called as chlorine molecule, that is Cl2, and you can see in the picture Cl single bond Cl, which represents a pair of electrons are going to be shared between the chlorine atoms. So chlorine, oxygen, whatever I am giving an example here, they are all considered to be as a non-metals, where we can able to see the sharing of electrons between the two participating atoms. One more example is the nitrogen. In the nitrogen, we can see the 3 electrons are being shared between the two atoms. So we can represent those 3 electrons in the form of triple bond. So in all these examples, what you have observed, children, it is none other than the similar atom is going to be participating. So when similar atoms are going to be participating, then those molecules which are going to be formed here are referred as what we call homoatomic molecules. So what are homoatomic molecules? Homoatomic molecules are those molecules in which similar atoms are going to be participate, where we can see the sharing of electrons between them. And there also we can explain whether it is similar or differ. We see that bond existence is what we call covalent bond. So these examples what I quoted now, the oxygen, nitrogen, chlorine, they are all examples for homoatomic molecules, because we are seeing similar atoms are going to be shared between them. Now next category is what we call heteroatomic. So heteroatomic molecules are given more importance for the carbon compounds, because in carbon compounds we see different atoms are going to be combined. And one more thing what you have to remember here is carbon is going to be combined with hydrogen more. So carbon has got more affinity to share with hydrogen atom. So all the carbon compounds are what we have in our day-to-day life, or what we are using the carbon compounds, all the carbon compounds containing carbon and hydrogen atoms. That's why we call those compounds as what we call hydrocarbons, because they're combination of carbon and hydrogen. So when I say carbon and hydrogen, both atoms are different, is it? So when such atoms are going to be shared, when such atoms are going to be participate in the formation of covalent bond, then the resultant molecules are referred as what we call heteroatomic molecules. So heteroatomic molecules are those molecules in which two different atoms are going to be combined. Let us see an example here now. Let us take an example here which is known as methane molecule. I think you are all familiar with the compound name methane. So methane is popularly known as marshy gas, because this is a compound which is going to be formed when there is a decomposition activity is going to be taken place. Whenever there is a decomposition activity, a foul smell is going to be appear, which is none other than a methane. So when you look into the methane here, we know that methane formula is CH4. We shall discuss much more in the next sessions about all those things now. Just to concentrate here how the bond is going to be formed. So methane is CH4. CH4 means one carbon atom and 4 hydrogen atoms. You can see that structure in the image. There is one carbon atom, surrounding there will be 4 electrons, and each hydrogen atom is bonded with the carbon with single electron. Is it? So C is having how many electrons in the valence shell? That is, carbon is having 4 electrons and hydrogen is having 1 valence electron. So one carbon atom is bonded with 4 hydrogen atoms, which means that one carbon atom is sharing the electrons with what we call the hydrogen atoms and forming what we call CH4 that you can see in the complete formation of the structure, where we can see totally how many electrons. C is having 1 electron and H is having 1 electron. C is having 1 electron, H is having 1 electron. So both carbon and hydrogen, each carbon, hydrogen will have a pair of electrons, and totally it will be having 6 electrons are going to be shared between the carbon and hydrogen atoms. So this is one of the example you can give for the covalent bond in carbon compounds. Let us take another example here. Again, another important example we can give for this one is ethene. Ethene is also one such compound of carbon, where we can see having a double covalent bond can be existing between them. So we can see instead of in the case of methane, a single bond is going to be formed, whereas in case of ethene we can see what we call double bond between the two participating atoms, which is known as carbon. So between the carbon atoms we can see the 2 bond, and between the carbon and hydrogen we can see what we call single bond. So totally if you look into the number of electrons that is going to be shared between the carbon and hydrogen is 2 plus 2 is 4, 6, 8 and 12. So totally 12 electrons are going to be shared between the carbon and hydrogen, and resulting in a molecule called as ethene. You can see the picture in the slide now. So one carbon atom and another carbon atom, how it is going to be shared and how the electrons are going to be shared between the two participating atoms, and also you can see how carbon and hydrogen is also making a compound here. So another example you can give for the carbon compound is the ethyne molecule. Even in case of ethine, you can see what we call the second structure. What you are going to see, first one is nitrogen. Once again, that is a non-carbon compound, but second one what you are seeing is the carbon compound only, that is ethyne. In the ethyne, you can see 2 carbon atoms are participating and they are going to share with 3 electrons. That means 3 bond you can see here. We show that 3 pair of electrons are going to be shared between the carbon atoms. So totally we can see 8 electrons are going to be shared between the carbon atoms. So those 8 electrons, how it is going to be shared can be seen in the form of a dot-like structures, or you can also see that dot-like can be represented in the form of what we call a bonded-like structure, or a single line like a triple line and single line which you are representing here, and none other than the sharing of electrons between the carbon and hydrogen. So all these methane, ethene, ethyne are all examples of what we call carbon compounds, where we can see how the electrons are going to be shared between the two participating atoms, and these are referred as what we call heteroatomic molecules. So let us look into the properties of these compounds now. So what are the properties of covalent compounds? As I told in the beginning, so ionic compounds totally differ from covalent compounds, or we can say covalent compounds are totally different from ionic compounds because of the bonding establishment between them. So covalent compounds will have so and so properties. So those are like this. Number 1, they are mostly gases. So all the covalent compounds are existing in gaseous state. So all the covalent compounds have low melting point and boiling point because of free electrons. All the covalent compounds dissolve in organic solvents. They do not dissolve in water. They dissolve in organic solvents like benzene, ether. These are all some of the organic compounds in which these compounds get dissolved. And covalent compounds are poor conductors of electricity. They don't have free electrons at all. They have absence of free electrons. Because of absence of free electrons, they have low melting point and boiling point. And because of another important thing, because of that absence of free electrons, they also do not conduct what we call electricity. So covalent compounds are poor conductors of electricity. Covalent compounds have low melting and boiling point because of absence of free electrons. Covalent compounds never dissolve in organic solvents, and covalent compounds are mostly gaseous in nature. So students, with this we have completed a few concepts of covalent bond, how it is going to be formed in the carbon compounds, and we have seen certain examples how the covalent bond is going to be formed in these compounds. So in the next session we'll discuss more concept of this chapter. Till then, bye. Thank you.